We'll proceed in calculation of surface area of a circle. I mean, pseudo calculus problems. Okay, this is a promise that we will have very, very interesting problems in the through the pseudo calculus problem series that we have started, where we are tackling into solving the solving the mathematical problem, and probably through the calculus, or probably through the vector. Okay, in that fashion, we are still in phase of calculating the surface area, or rather, I say the area of a circle. Okay, area of a circle. What is area of a circle? Now, in that fashion, in calculating the area of a circle, we started using spherical coordinate system. And through spherical coordinate system, we were trying to calculate surface area of a circle. Okay, so what it is sphere? This is a sphere. So this is the sphere that we are using to calculate the surface area of a circle. Okay, is it really a sphere? Consider this is a sphere. This is very, very heavy though. Now, the any sphere or a spherical coordinate system, there are three coordinates. There are three orthogonal components. One is one is r, that is radius of the sphere. One is theta, and one is phi. One is radius of the sphere, one is theta of the sphere, and one is phi. Okay, phi. Okay, so there are three orthogonal components. What are the coordinate? What are the components in any coordinate system? Okay. I have Cartesian coordinate system. Then what are the components of Cartesian coordinate system? Okay, I have a spherical coordinate system. I have polar coordinate system. I have cylindrical coordinate system. Is there anything common among these coordinate systems? Certainly. No, there is no common. I have in Cartesian x, y, and z, where in polar we have r and theta, and then in cylindrical we have r, theta, and z, where in spherical I have r, theta, and phi. So all are different, all are same. Any coordinate system comprises perpendicular coordinates. All coordinates must be perpendicular to each other. Then only it is coordinate system. And coordinate system typically it talks about the three coordinates. In Cartesian, it is x, y, and z, where is in polar, that is for spherical area, that is for area. It is radius and theta. Now radius is distance and theta is angle. And for a cylinder, radius theta and z, and for a spherical, radius theta and phi. So in the spherical, two are angle and one is distance. Okay, if that is the case, then if I say, if consider this is center at the origin, this is a sphere and centered at the origin. What do you mean by center at the origin? Okay, this is origin. This is origin. This is x-axis. This is origin. This is y-axis. This is origin. This is z-axis. This is origin. This is xz plane. This is yz plane. This is xy plane. Now, in that case, it is centered at the origin. The origin I talk 0, 0, 0 is center of this sphere. Okay, too much rain out here. Okay, so this the center of this sphere, that is origin, and from origin means this is center at the origin. This is x-axis, this is y-axis, and this is z-axis, or this is r theta plane, and this is how I can say in a spherical coordinate system. Anyway, in a spherical coordinate system, if I talk, this is center at the origin. Half of it is above xy plane and half of it is below xy plane. If I take any point P here, what is coordinate of this P? Okay, if I talk in a spherical Cartesian coordinate system, that is x, y, z, that is P. Okay, What is P in the pure spherical? Pure spherical coordinate system is not available in any of the book. Anyone can try. What is the pure? Because book it is written that three coordinates of the spherical coordinate system in r, theta, and phi. That is true. Three coordinate of a spherical coordinate or three independent component of a spherical coordinate system is r, theta, and phi. That is 100% true. But I cannot say that there is any point on this sphere and this point is x comma y comma z. That I can say. But this point is r comma theta comma phi. That I cannot say. Not possible. Because r is distance and theta and phi are angle. Okay. I can say that okay, this is r comma theta comma phi. This point is means if I take this plane, horizontal plane, if I take, then if I take radius there, then if I move theta, then it will hit it. And then in vertical, if I radius is there and if I move phi, it will hit it. But if I talk about the coordinate of this, then all three should be in distances only. After all, it is a distance from the origin or whatsoever. Okay, in that fashion, r comma theta comma phi will be replaced by r comma r sine phi. Because if this is radius of a sphere, okay, if this is the radius of a sphere, this is radius of a sphere, and this sphere is centered at the origin. If it is centered at the origin, and this is the radius of the sphere, the radius will make phi angle from the vertical, and radius will make theta angle. If this is the radius, at any moment, what is your radius? Any moment, if I take any moment radius is on xy plane, then it is making phi angle with the vertical, and then it is making theta angle with the x-axis anytime. But anytime, this is a generic, but more generic is if I take radius anything that is not on xy plane. What is more generic position of radius in a sphere? The most generic position of radius in a sphere is anywhere. It can be in xy plane, it can be anywhere else. If I take xy plane, then phi is 90 degree, and then theta is from x-axis. Okay, then this arc, what arc it is making on xy plane is arc r into theta, whereas this arc that it is making from the vertical, arc that is making from the vertical is r sine 90 degree. That is not variable. If I take the radius on xy plane, then phi is fixed. Phi is not varying. Theta is varying. But if I take radius anywhere not in xy plane, then phi is varying, because here phi can be anything. On xy plane, phi is fixed. The vertical angle phi is fixed at 90 degree. We want all three to be variable. In that sense, I can take radius of a sphere that is not on the xy plane. It is at phi angle from the vertical. In that case, the point it will show here, P point, I take any P point, it will be r, that is the radius, comma r, this is phi, r, this is r, sine phi will fall on xy plane, r cos phi will be the vertical, r sine phi will fall on the xy plane. Now here, so radius on the xy plane is r sine phi. R sine phi theta is arc on the xy plane. R phi is the arc on vertical plane. Now if I talk about any point P here, then it is r comma r sine phi theta comma r phi, because when we are taking any point here, all three should be in length. R is a length, r sine phi theta is the arc on xy plane, that is also a length, and r phi is the arc length in vertical. Now in that way, we have a position vector that is going from origin to point P is r unit vector, because it is in r direction, r unit vector. Someone can say r vector, but it is r magnitude r unit vector plus r sine phi theta theta unit vector plus r plus r phi unit vector. Anyway, we are in phase of calculating the surface area of a circle that is formed in r phi plane, where theta is constant. Okay, I would demonstrate it. Let's cut this sphere at xy plane at the center. If I cut it, then it will form a circle. If I cut this sphere in r phi plane, where phi from vertical phi is varying, so I make a cut like this. In that fashion also, it will make a circle. That is that is r phi plane, and this is r theta plane or r sine phi theta plane. Now, in that fashion, if I do like that, if I cut in that fashion, okay, now this is r theta plane. Now, I'll make it vertical. Rotate it. Now consider that this is x-axis. Angle theta is 0. Now I move angle theta here. Now this is new theta. This is x-axis. This is x-axis, and this is it moved angle theta. Now at this angle theta, if I move up like this, okay, actually it is horizontal, r theta plane. Now I move any theta angle. So here I move a theta angle here. Now if I make it again and then I make a cut like this. If I make a cut like this, then theta is constant everywhere in the cut. So when theta is constant, I am making a cut in a vertical plane. It will form a circle at any angle theta. That is the concept. What is the area of the circle? That is the area of circle. So here, if I make a cut, now at any angle theta, this is the angle theta I took as constant. Now I take any angle theta. There at this theta, if I go up, keeping theta constant, it will make a cut again. This I can call it longitudinal cut. If I take a phi constant, if this is angle is phi and take a phi constant and then I make a cut, this is latitude cut. So at every cut, the surface area of the circle it is forming is different. That we have calculated in a large scale. Whereas that is called phi constant, keeping a phi constant. Now keeping a theta constant, if I make a cut, then everywhere it will form a circle and circle radius will be the radius of the sphere. That is called longitudinal cut. What is the area of a circle in longitudinal cut? Because longitudinal cut, if I calculate the area, if I make cut in longitudinal way, if I make a longitudinal cut, if I make a longitudinal cut, okay, if I make a longitudinal cut in this fashion, then it will form separate circle. But all circle will have same radius, that is radius of the sphere. If I make a latitude cut at a fixed height, if I make a longitudinal cut, it will be at a fixed theta. If I make a horizontal cut, it will be at a fixed height. Okay, in horizontal cut, latitude cut, everywhere the area of the circle will be different. Everywhere. The area of the circle, everywhere it will be different. Now we have calculated the area of any circle that is at phi angle is pi a square. A is the radius of a sphere. Pi a square sine square phi. This is what we have calculated. So at every phi angle, if this is the radius and this is phi angle and this phi angle, I make a cut. Then another phi angle, I make a cut. Then phi is 90 degree, I make a cut in xy plane where radius is a. In that fashion, at any particular phi, if I make a cut, the area of the circle is pi a square sine square phi. It is function of phi. But if I keep theta as constant in xy plane, I make a cut vertically everywhere, the circle will have same radius a. This proves that if I calculate area of the circle, it should not bring the function as theta. Okay, I believe it is all right. So let's proceed calculating the surface area of a circle. Now, what is the surface area of a circle that we have calculated? We have calculated surface area of a circle. I'm sorry, surface area in surface area. Okay, we'll start again. What is surface area? If I take any point P here and from center if I draw a position vector, this position vector represent a point P on a surface. If I calculate derivative of P, then it will give the surface area vector. That's simple. If it is xi plus yj plus zk is the position vector connecting origin and point x comma y comma z, then surface area vector is d of p, means dxi, d of p, d of in bracket xi plus yj plus zk, dxi plus dyj plus dzk. Now, if that is the case, then the kind of if that is the case, then the area vector is surface area vector d of p, dxi plus dyj plus dzk. Was it that simple? It is that simple. Anyway, this is called pseudo code. We cannot calculate surface area in this fashion. Then we saw that d of p is same as d of p by d of r theta into d of r theta, or d of p is same as d of p by d of r phi into d of r phi, or d of p is same as d of p by d of theta phi into d of theta phi. I can multiply by an item and divide by the same item. Here what we need, what is varying when I am making a vertical chop of the sphere. If I make a vertical chop on the sphere, then what is fixed? Theta is fixed. R and phi are varying. In that sense, we will say our d of p, that is the area vector, is same as d of p by d of r phi into d of r phi, small d r phi, derivative of r phi, because r and phi are variable, into d of r phi. What are we trying to calculate? We are trying to calculate the surface area on around the P. If this is P, then what is surface area around the P if there is 1 unit of surface area change in r phi plane, dp by dr phi, where dp is area vector, dp by dr phi. R phi is a two-dimensional coordinate system where one axis is r and one is phi. In that coordinate system, if I make in that where one is r and one is phi, in that coordinate system, if I make 1 unit of area change, how many unit of area change I would see in the P? What are you talking about? Okay, I'll talk what I'm talking about. So on the sphere, I have a point P on the surface. Now I have XY plane. Down the line, I have a XY plane, on top of which there is a sphere. On top of it, there is a point P. Now P has coordinate x comma y comma z. Z is the height, where x comma y is intersection on xy plane. Now I have xy plane, and consider there is another plane called r phi plane. R phi coordinate system, xy coordinate system. On top of xy coordinate system, I have a sphere, and there is a point P here. Okay. Now, if I in r phi coordinate system where one axis is r and one axis is phi, or this axis is phi and this axis is r. Now here, if I make 1 unit of area change, what is area change? The area here, any point on r and phi, is related to point in xy plane. X equal to r sine phi cos theta, where theta is constant here. More or less, I'll say x is function of r and phi. Y equal to r sine phi sine theta, where theta is constant. So y is a function of r and phi. These explanations are not available in any of the book. Now I have r phi plane and xy plane. On top of xy plane, I have a sphere where z is also there, where P point is there, and around P where I have a surface area vector. Now, if now x and xy and r phi are related to each other, x equal to r sine phi cos theta, y equal to r sine phi sine theta, means x is a function over r and phi, theta is constant. Y is a function over r and phi, theta is constant. Now, in that fashion, if I have a 2D shape on, if I have a 2D shape on the theta r plane, if I make 1 unit of change in, I'm sorry, if there is a 2D shape on theta r plane because every point on r and theta plane is mapped to point on xy plane through relationship x equal to r sine theta, x equal to r sine phi cos theta, y equal to r sine phi sine theta. Now, if I take a set of point here, there will be a set of point here also with this relationship. Now, I am saying at any point r comma phi, if I make one unit of change, maybe around the r comma phi or after r comma phi, if I make one unit of area change, then how many unit of area change I see at point P via this xy plane? One unit of area change here will bring some unit of area change here, because if I take a one area, then that area will be mapped into some other area in this plane because they are related to each other. Now, if in that area, if I make one unit of area change, how many unit of area change I see? If I get that much unit of area change in xy plane, accordingly, how many unit of area change I see around P? That is dP by dr phi. In r phi plane, if I make one unit of area change at point P, how many unit of area change I am seeing? dP by dr phi. In r phi plane, if I make one unit of area change, then there will be unit of area change in x and y. And then via media, we will have area change at point P. Now, in that fashion, please watch our previous video. So, in that fashion, dP by dr phi into dr phi is same as dP by, now here, so to make it more, rather than one unit area change, I'll take one small area, delta phi delta r. Now, I'll make change as delta phi delta r, and then I'll see the change in xy, and then I'll see change at point P. It is not very difficult. Anyway, if someone understands, then it will become cross product of two vector at point P here. P, if there are 3 points here, phi comma r, and I make a delta chain, means phi plus delta phi comma r, and then I make a r chain, then phi comma r plus delta r. There are 3 points. Phi comma r, phi plus delta phi comma r, phi comma r plus delta r. Accordingly, there will be 3 points here also, and 3 points, one will be considered as vector, another will be considered as vector. Cross product of these two vectors will give the area change here, and this cross product of these two vectors, okay, I believe I can keep quiet here. Now we have 3 points here also. One point corresponds to r and phi, r comma phi comma r. One point corresponds to r phi plus delta phi comma r, and one point corresponds to phi comma r plus delta r. Accordingly, on the surface at point P is represented by phi comma r via media. Now point P, around point P there are 2 points. One represents phi comma r, one represents phi comma r, and then z. What is z? Okay, I can say x equal to g phi comma r. X is a function over phi comma r. Y is a function over phi comma r. Then z is function over x and y. If I represent any point x and y here on the xy plane, x comma y, then x comma y, any point is same as g phi comma r, any function over phi comma r, comma h phi comma r, comma. If I represent z on the point z as point P, if I take a sphere, then point P is x comma y comma z, then that point can be represented as x is g phi comma r comma h phi comma r comma z is function over x and y, f function over bracket open x comma y, g phi comma r comma h phi comma r. Anyway, on the surface I have a point P, and that coordinate is x comma y comma z. If I move to another point, that is phi plus delta phi comma r, and another point phi comma r plus delta r, accordingly there will be 2 points there also. One is P and one is P1. P1 corresponds to phi plus delta phi comma r, and P2 corresponds to phi comma r plus delta. If I take cross product on the surface, this will give me the area that I receive because of delta phi delta r change in the phi r plane, dP by d phi r. Okay, Now d of phi r will change into delta phi delta r. If there is a delta phi delta r change happen in phi r plane, how much change I see in the P point? That will be 3 points I talked about. One I consider P, what the original point is P, that is x comma y comma z, means that is corresponding to here theta comma phi. P P1 new point, that is phi plus delta phi. P2 new point, that is phi comma r plus delta r. If I take cross product of P1 P and P2 P, I get the area in the position vector around. dP by d theta r is same as P1 P cross P2 P by delta theta delta r. That side we had d theta r, that also we written as delta theta delta r. Now it becomes P1P cross P2P by delta theta delta r can be written as P1P by delta theta cross P2P by delta r. Now this first one P1P by delta theta, if someone calculated, it will become dP by dr, dP by d theta cross, sorry, dP by d phi. I'm sorry if I said theta anyway, that is phi. dP by d phi cross dP by dr into d phi dr. This is typically called area vector. But what is this area vector? This area vector corresponds to area that is in phi r variable. Theta is constant. So that area I am talking here is not this surface area. Is not this surface area. This surface area is where r is constant and theta phi are variable. I am talking about this vertical surface area that I will cut and get a circle. There theta is constant and r and phi are variable. And that surface area what I am getting is dP by d phi cross dP by dr into d phi into d delta phi delta r d phi dr. Now if I calculate this area vector magnitude, I'll get the area of the circle. Now what is P? P is xi plus yj plus zk dP by d phi, where x is r sine phi cos theta I. So dP by d phi is d of r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k by d phi cross product. D of r sine phi cos theta j plus r sine phi sine theta, I'm sorry, d of r cos, I'm sorry, d of r sine phi cos theta I plus r sine r, I'm sorry, d of r sine theta cos phi I plus d of r, d of in a bracket, it is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k by dr. So first is by d phi, another is by dr. What is by d phi? It will become r cos phi cos theta I plus r cos phi sin theta j plus r minus sin phi k d cos theta by d cos phi by d phi. So it becomes r cos phi cos theta I plus r cos phi sin theta j plus r minus sin phi k cross product by dr. R will go away from everywhere. Sin phi cos theta I plus cos phi sin theta j plus cos phi k. Someone has to do cross product of these two. Okay, we will do it. We will do it. We are not running away. We will do it. So what is cross product of these two? If I calculate the cross product, now we have I and I cross product is 0. I and j cross product will be k. So it will be r cos phi cos theta and that side sin phi sin theta. Okay, r cos phi cos theta and that is sin phi sin theta. It become r. It become r cos phi sin phi cos theta sin theta k. If I take another k, that is first side j and another side I, if I do cross product, it becomes minus k. And this side r cos phi sin theta, and this side sin phi cos theta. So both are same, r cos phi sin phi cos theta sin theta k. But another side it is same thing, r cos phi sin phi cos theta sin theta k, but it is minus. So k component will go away. There is no k component in the area, certainly. There is no k component in the area indeed. Because if I make a vertical cut, if I make a vertical cut, then area will be vertical. The circle that will come, it will be vertical. If it comes vertical, then everywhere it will have a area vector is perpendicular to the surface. Area vector will be in I and j only because that will point toward xy plane. There is no vertical component in the area vector. So k is 0. Amazingly beautiful. This is not available in any of the book. Amazingly beautiful. There is no k vector at all. So k is 0. Let's try with the next. Now I cross I 0, I cross j k, that is also 0. I cross k. I cross k will be minus j. What is minus j? I cross k is minus j. Now I have r cos phi cos theta, and that side I have cos phi, only cos phi. It becomes r cos square phi cos theta. Okay, minus I cross k minus j r cos square phi cos theta minus j. Now we will try with this j component here. If I take j component here, then j cross I will give the k that we have settled down. J cross j is 0. J cross k will give the I, and that I is r cos square phi sin theta. Okay, j cross k will give positive I. So we have I and j component. One is r cos square phi sin theta, and one is r cos square phi cos theta. Now third term is also there. That is r minus sin phi, r minus sin phi k. If I do cross product, then I can do this cross product with I and j. K cross product with I will result into j, and k cross product with j will result into I. So I have one more I and j component. What is I? Here I have minus r sin phi, and this side sin phi cos theta. It will become r sin square phi cos theta, r sin square phi cos theta, and then k and j will become r sin square phi sin theta. Okay, what is the end result? What is the now we have four computation. One computation is for I, and I become when I did cross product of j on the first side and k on the other side. So it become r it became r cos square phi, sin theta. That is I. R cos square phi sin theta. Because this side sin theta and cos, and that side cos. R cos square phi sin theta is I component. Either negative or positive, leave it for right now. Okay. And then I component is here, it is first side k and this side j. Then it is r cos, then this side r sin phi and sin phi, r sin square phi, sin theta. So it is now r cos square phi cos theta. Both will be minus, same sign will be there. R cos square phi cos theta, and one is r sin square phi. One is r cos square phi sin theta, and one is r sin square phi sin theta. I. If I settle down this I, it becomes cos square phi plus sin square phi. Okay, then that is 1, that is become r sin phi. It only becomes r sin phi, that's it. R sin phi I vector. Now let's settle down j. If I settle down j, then first j is I and k. If I do cross product, it becomes j. Means r cos phi cos theta, and that side r cos phi. It cos phi, only cos phi. So r cos square phi cos theta. That is j, one j. Another j will come when k will do cross product with I. In that sense, it is r sine square phi cos theta. Means it will become r cos square phi cos theta j and r cos square phi cos sine square phi cos theta. It will become r cos theta. Now we have now r sine theta I plus r cos theta j. This is the net cross product. Now, so our now area vector is r sine theta I plus r cos theta j bracket close d phi dr. Now, what is magnitude of this? R will go out sine square theta plus cos square theta 1 only, and then a square root. Magnitude of this will be R only. Now, the area vector is area magnitude is R d phi dr. R dr d phi. If I do if I do the if I do the cross product of this, if I go with the integration r dr d phi, then r square by 2. R radius is 0 to a square by 2. Phi 0 to 2 pi. 2 pi. Pi a square is the area of a circle that falls in vertical line. Pi a square. It is not function of theta. Means everywhere you make a cut, it will give the same circle and radius is pi a square. Amazing, mind-blowing, thrilling, head-storming, and brain head hitting in the wall. Okay, we will see other things also. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. The way I took dp by dr phi to calculate the surface area in the r phi plane, if someone take dp by d theta r, theta phi, then he will get surface area of the bond of the sphere. Amazing, mind blowing.